Alrighty, so here's our read and got it's, and I brought the steps along with me for the fun of it. Up here, I know you like that. What is the solution of this equation? So again, we write down, double check to make sure you wrote it down correctly. And we're assuming since the people who made the book, they did write it down correctly. There is no distributive property here, so you can skip that second step. There are no like terms to combine, so I can skip that step. So now we're adding and subtracting to get the terms on, so variables on one side and constants, that's the numbers on the other. So in other words, I want to get the numbers over here by themselves and the variables on this side by themselves. So notice there's the equal sign. So I want numbers here, variables over here. So I subtract to get rid of that 3. Again, we're looking at inverse operations is the idea. So subtract the 3 from both sides to get rid of this 3. We end up with 2x equals 12 because 15 minus 3 is 12. Now we're down to the multiply and divide phase. So we want to get x by itself, so we divide off the 2. So x is 6. That last step, the check, we plug back in a 6 for our variable of x, and we work it out following our order of operations. Always start with the original, not some other version that you came up with. So 2 times 6 is 12 plus 3 is 15. It works out. Now, as we're doing just two-step equations right now, pretty much the first, second, and third steps, second and third steps can pretty much be skipped over at this point. So again, make sure you write it down correctly. So I'm going to go 5 equals t over 2 minus 3. And again, I have no distributive property, no like terms to combine, so I'm down to the add and subtract phase. So I'm going to go ahead and add that 3 on both sides. So I get 8. See, there it is. 8 equals t over 2. Now I'm to the multiply and divide phase. I want to get that t by itself. The inverse operation of dividing by 2 is multiplying by 2. And I'm going to show that on both sides, please. 16 equals, and these 2's cancel out, so it's just t. So t is 16. Not done yet, though. Don't forget that check. And so I take my original equation. Again, original equation. Plugging in 16 for t. And I solve it. So 5 equals 16 divided by 2 is 8 minus 3. And that is indeed correct. So my answer of t equals 16 is correct. I would ask that you also get in the habit of circling your answer. Make my life easy when I'm grading. I don't just look at the answer, but that's the first thing I look for. And then I go back and make sure your work matches it and look through it there. And I do assign points accordingly. Alrighty, so using an equation as a model, you're making a bulletin board to advertise community service opportunities in your town. You plan to use half a sheet of construction paper for each ad. You need 5 sheets of construction paper for a title banner. You have 18 sheets of construction paper. How many ads can you make? So please note on this one, we're taking off 5 right off the top, right? And we left with 13, and we're using a half sheet. So half of each sheet, right, plus the 5 that I'm taking off the top to use as the banner is 18 total sheets. And again, A, don't forget, write your let statement. A is the number of ads you can make. So half a sheet per ad plus the 5 for the banner is 18 sheets. So in here, subtract the 5 from both sides. 1/2 A is 13. And again, notice we didn't have like terms to combine, no distributive property. Getting rid of the multiplication by 1/2 by multiplying by its reciprocal of 2 on both sides. So A is then 26. You can make 26 community service advertisements for the bulletin board. Similar problem here, actually the same problem, only this time we're changing it up. Suppose you use 1/4 of a sheet of paper for each ad and 4 full sheets for the title banner. How many ads could you make? So we'll move that out of the way here. Again, we already have our let statement there. Don't forget that A is the number of ads you can make. That is important. So it's going to look very similar. So I said that this time I still have 18 sheets, right? And 4 of them are going for the banner this time, not 5. And each I'm going to make quarter sheet sized. So there's my 1/4 quarter sheets, right? So subtract our 4 from both sides. And we find out that 1/4 A equals 14. Using our reciprocal, so power is a reciprocal, right? Multiply both sides by 4. Cancels out the fractions here. A then is 56. And the answer is ads. Got to label as ads, but we do need to check that first. So 1/4, let me make a little bit of room here. 1/4 times 56 plus 4 equals 18. 1/4 of 56 is 14. So 18 equals 18. And so my answer, 56 adds, is correct. Okay, so now here's where it can be changed up a little bit. Hang on a second, I'm going to pop the steps. Alrighty. So, steps for solving equations. So again, same thing here. This time though, it changes the order a little bit when I have, I call it an all multiplied by, or an all divided by rather in this case. The entire side here is divided by 3. So I cannot start by adding 7 to both sides. So the order here changes a little bit. I need to get rid of this 3 because in this case, the fraction bar is acting as a grouping symbol. In this case, we can see that we're going to multiply, and we'll leave their work right here, multiply both sides by 3 to get rid of that. Again, that cancels out the 3 here, and so we find that x minus 7 is what's left over, equals negative 36. Now we can add to get rid of the 7, and we find that x is 29. And then you'd run your check and prove that that's true. But again, in this special type, please note that you will multiply before you add or subtract. So it changes the order a little bit. Again, when the whole side is divided by something, it changes the order a bit. Okay, so again, on this one, it's going to look a lot like the one we just did, where you're going to have to multiply before you add or subtract. So the problem here in this case, we have 6 equals x minus 2 over 4. And again, our order of solving is going to change a little bit because I need to get rid of the this 4 because the fraction bar is acting like a grouping symbol. So in that case, we're gonna fix that issue. 6 times 4 is 24. On this side, the fraction cancels out the 4 here, or the reciprocal rather, I should say. So x minus 2 equals 24. Now we can go ahead and add to get rid of that 2 on both sides. So 26 equals x. Now we do have to do the check still. So the expectation here is that you plug back in that 26. So 6 equals 26 minus 2 over 4. 6 equals 24 divided by 4, and well, that's true. So our answer was correct. And the second part, write the right side of the equation as a difference of two fractions. Solve the equation. Did you find the equation of part A to be easier to solve? And I'm going to show you what that looks like here in just a second. So what they want you to do is to say the following. Well, 6 equals x over 4 minus 2 over 4. Same thing, right? They have common denominators, so you can do that. 6 equals, so now we're going to have to go back and we're going to add 24 to both sides. So what I need to do is get rid of this, I guess. So add 2/4 or 1/2 to both sides. So we're going to add, you know what, 1 second. Let me go back and clean this up again and leave it like it was. There we go. Now we're going to add 1/2 to both sides, right? And so we get 6 1/2, right? So 6 1/2 equals x over 4. Now I have to multiply off the 4. Well, I need to make this thing improper first, right? 6 times 2 is 12, so 13 halves, or 26/4 equals x over 4. And we can multiply off the 4 now on both sides. And so this would really be following the actual steps, right? So you're sort of undistributing. That's what this part is, undistributing. So it's distributive property. And then you're going to add, subtract, and you multiply and divide. These 4's go away, and x we find is still 26. I don't know about you, though. I thought this was easier. Sort of a shortcut kind of way. So, but again, we can use the actual steps, and this involves distributive property technically to make this work. So we know we have lots and lots and lots of steps, or properties that we've learned, I should say, and so you can use those to justify what you're doing. So we're going to solve this. So you rewrite, we call it the original equation. Now, they're calling subtraction property of equality. We said we only had addition property of equality. They are the same property, so it doesn't matter. We're still going to add that, subtract that 8. Then we're going to divide off or multiply off the negative 1, depending on how you look at it. So, again, simplification, multiplication property of negative 1, Or I would accept multiplication property of equality because you're going to multiply both sides by it. And then there we are. There's our answer. T is 5. So again, when I say justify each step, I want you to tell me the names of the properties that you use at each line. Okay, so again, subtraction, in this case, addition property of equality, multiplication property of equality is acceptable instead of division property of equality. We've already learned the multiplicative property of -1. And things like subtracting and adding are just basic statements. So let's do that on the next slide. So we can see here, again, the original equation, x divided by 3 minus 5 equals 4. And we have the addition property of equality because we're going to go ahead and add that 5 to both sides. And then obviously this is called, I usually just write simplify. I don't need all this other fancy stuff. I can just say simplify, right? Then we're going to use the multiplication property of equality on both sides to multiply by 3 to get rid of the denominator. And then again, you could write the word simplify here, or nothing at all because that's what you're doing. And x certainly is 27. So there we have it.